Welcome to Study Loop.
For part A, we're dealing with double charged nitrogen plus. So normally nitrogen N has 7 electrons in the outer shell. So N sub E, number of electrons is 7, but we're dealing with N2 plus, so that's 7 minus 2 because we have 2 electrons removed from it to give us the 2 plus. So this gives us 5 total electrons. So our configuration for part A, we have 5 electrons we're needing to use. So let's start filling up our orbitals. So the first one that gets filled is 1s squared. The next one to be filled is 2s. We still have all the electrons we need, so we have 2s squared. And then next we have 2p. P can hold 6 electrons, but we've already used 4 of our 5, so we're only going to use 1 of those 6. So that's 2p to the first. And we can box that in as our solution for A. To find the energy for part B, the energy is equal to negative 13.6 electron volts times the times Z effective squared divided by the orbital that we're dealing with, N squared. Well, for the least strongly bound level here, and N plus, Z effective is equal to 3. So this is 13.6 EV times 3 squared. And then if you have configuration, we go to the 2p orbital. This is divided by 2 squares and is equal to 2. Plugging those values in, we find that equal to negative 36 EV. We can box that in as our solution. For part C, we're going to figure out the configuration for P plus, potassium plus. Well, potassium has 15, but it's 2 plus, so that we minus 2 from that 15 to get 13 total electrons. So our configuration, let's start filling it up until we use all 13 electrons. So 1s is going to be fully filled, so that's 1s squared. 2s is fully filled, so that's 2s squared. 2p can be fully filled, so that's 2p to the 6th. We've used a total of 10. Next, we come across the 3s, which can be fully filled, so that's squared. So now we've used 12, so we can use one more. So we come to the 3p, and we're going to use one of the 6 there. So that's our configuration. You can box that in. Now the energy. Again here, the least strongly bound level, Z effective, is equal to 3. So therefore, and then also, according to the above, the highest configuration we get to is the N equals 3 configuration. So N is equal to 3. So this is negative 13.6 EV multiplied squared divided by 3 squared. So this gives us a value to negative 13.6 electron volts. We can box that in as our solution.